and welcome to Wednesday's edition of Cracking the Cryptic, where today we're going to take a look at a very amusing looking puzzle called the Scrabblebag Equilibrium by Olimar. Now, those of you who are familiar with the channel will know that I have a proclivity for describing set theory, one of the sort of one of these new Sudoku techniques. My way of describing that is using Scrabble tiles and Scrabble bags, and Olimar has presumably taken that and has embedded it into this Sudoku. We've got two green bags. They should be different colours, really, Olimar. They really should be different colours. But apparently this one is approachable today as well, so maybe it doesn't need set theory, although I'm a bit suspicious about this cage here. Anyway, I'll read the rules of this one in just a moment. My first job today, though, is to say a very happy birthday to a young 5-year-old girl down in Sydney called Lana. Now, Lana, your mummy, Samila, has been in touch with me and says that you enjoy watching the channel, which is absolutely amazing. I hope you enjoy it. I hope you enjoyed today's video especially. And with it being your birthday, I hope you have a great deal of cake, hopefully chocolate cake. I'm sure it's chocolate cake. You let us know. Anyway, other big news. In just an hour's time, but this will have already happened when you're watching the video, we will have released on Patreon these two Sudoku packs of puzzles. These are the Japanese Sum Sudoku themed puzzle packs from Panthera, the Asylum and Grockles, no less. One of them is sort of, how can I describe it? It's a few puzzles, all very interesting. And if you get through those, send in the solution and you'll be in with a chance of winning a prize. And then there's the doctoral pack, which I'm going to be intrigued actually to see. I know some of you will finish it because we have this just incredible solvers on the channel. But how many of you actually managed to get your way through the whole of the doctoral pack? I'm going to be interested to see. Yeah, there's a competition running for that one as well. So do let us know how you get on. Do let us know how much you enjoy the packs. We would be most grateful to hear, and we'll pass on obviously the feedback to the setters too, to whom we should say a great big thank you for helping us out and for making our patrons so happy. Now, I've got no other news though today, so let us get on with finding out what's going on in the Scrabblebag Equilibrium and see what Olimar's got in store for us. So, the rules are as follows. Normal Sudoku rules apply. Digits in cages do not repeat and sum to the brackets given total. I see. Right. So, we actually could use the secret to deduce the value of this cage. It doesn't have a clue, you can see, but you can tell it's got 9 cells in it, and there is a clue there because digits can't repeat within cages as to what the total of that cage is. The secret is 45. Now, squares indicate even digits, so we've got loads of squares dotted around. These all have to be even cells, and adjacent digits on a green line differ by at least 5. So I think I did German whispers yesterday. This is the name given to this green line constraint. I think probably because it was first introduced by a German setter, but I might be wrong about that. Was it Christoph who did this? It might have been Christoph Seeliger. You will correct me if I'm wrong. Anyway, so how does it work? Well, let's imagine this cell was a 1. Now this cell would have to be at least 5 different from 1, so it has to be 6, 7, 8 or 9. Let's imagine this was a 9. This now has to be 5 different from 9, so it's got to be 4, 3, 2 or 1. Actually, these ones don't see each other, so we could have had any of those digits. Do have a go. The way to play is to click the link under the video as usual. And now I get to play. Let's get cracking. And I can see 2 things straight away. I might start with... Actually, well, let's start with the 28 cage, because this might be more powerful. The 28 cage there, I think that's a 7-cell 28 cage. Now, imagine it was a 9-cell 28 cage. No, don't imagine that. Imagine it was a 9-cell cage. Then we would know it contained all of the digits from 1 to 9, because it could have no repeats. And the secret, of course, which I alluded to here, is that the digits 1 to 9 add up to 45. So this cage is missing two digits from the digits 1 to 9 and adds up to 28. Well, if we take out the biggest 2 digits, the 8 and the 9, then we would find that the remaining 7 digits added up to 28. So we know in fact this is a minimized cage. It contains the triangular number for 7, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And therefore there are no 8s or 9s in this cage. Now, right, okay, I can see one deduction from that. There's probably many, but the deduction I'm seeing from that is I'm asking where 9 goes in row 4, and I think it's got to go over here. So now I'm asking where 9 goes in this cage. We know this is a 9-cell cage, so it contains every digit. It must have a 9 in it. So the 9 is in one of those 4 cells. And I'm pretty sure this is not how you're meant to start the puzzle. Let's instead look at this this 24 cage down at the bottom of column 4. That's got to be 7, 8, and 9. That's the only way of getting to 24 in 3 cells. And that looks to me to be very powerful, because look what's happened to the bottom of our Scrabble bag. Our Scrabble bag has got a 7, 8, or a 9 in it on its whisper line. And that's massive, because if you know anything about German whispers lines, there are only actually 2 things to know about German whispers lines. The first is you can't ever put a 5 on them, because if you do, the next digit along has to be 5 away from 5, so we're either in 0 or negative territory, or 10 or higher territory. That doesn't work. So we have to have either what we call a low digit, i.e. a 1, 2, 3 or 4, or a 6, 7, 8, 9. And the reason I divide it into those categories is watch what happens here. If this was a low digit, what's the next digit along the whispers line got to be? Well, it's got to be 5 different from this digit. And even if I pick 1 here and make this digit 5 different from 1 only, it still reaches the total of 6. So this digit always has to be the other side of 5. And now think about this digit. Well, even if I make this a 9 and deduct only 5 from it, I still slip under the 5 again. So we get this oscillating effect. And this is so important, because once we know this digit is a high digit on a whisper line, we can actually, let me try and do this. I meant to use sunny, I meant to say it's a hot digit, a high number. So I use a sunny colour, and we're going to be able to oscillate along the line and make all of those cells, I think, have to be high digits. So all of these are 6, 7s, 8s and 9s. And the corollary of that, of course, is that all of the other cells on the line are cold digits. Cold digits, 1s, 2s, 3s and 4s. Now we can probably do better than this though, because there will be some, yes, okay, this can't be a 6, because 6 on a German whispers line can only be next to the digit 1, because we need a digit that's 5 away, and that's going to repeat 1 in this row, so that can't be 6. This one could be 6, because those 2 digits don't see each other. Rather irritatingly, that one can be 6 as well. And now, actually 6 is very easy. That's weird. I suppose it's because our Scrabble bags are so bendy that we're actually able to put extreme digits on the whisper line. Let's check 4s. They have the same property, but with 9. Yeah, this can't be a 4, because that's going to require double 9 in the same box, so that won't work. This would require double 9 in those cells, so that won't work. That one could be 4, because it could have 9 on both sides of it. This one can't be. A 9 on both sides of it would be in the same row. Oh dear. Okay, so that was nearly useful, but not quite. So what are we missing now? Right, okay, well, there's certainly a restriction in column 2 now. And that's because we can think about the set of digits 1 to 9, which we know will appear in this column, and ask how many even digits are in the digits 1 to 9. And the answer is there are 4 even digits, 2, 4, 6 and 8. And they must appear then in those 4 cells. So that means these cells cannot contain even digits, which means that one can't be 6 or 8. I've just noticed it can't be 9 either. Hang on, we'll come back to that. Let's just get rid of the... Oh, this is good. This is very good. Right, so now we are getting somewhere. Because this little digit here is in my 28 cage, which we said couldn't have 8 or 9 in it. So now that's a 7, and that's a digit we've got, and that's a 9 by our old friend Sudoku. 7 can't be next to a 3 on a whisper because 7 and 3 are only 4 apart, so that's got to be a 1. So this has got to be a 1 or a... Oopsie. This has got to be a 1 or a 2 now. This is a 2 or a 3, so it can never be next to 6. This is not 6, so this can't be 1. This is... oh no, okay, this is high, so we're not putting pressure on this digit yet. Or in fact, these seem to have loads of options as well. Okay, so have we exhausted the use of our left-hand Scrabble bag? We may have done. Right, well, one other thing. Because we know that the even digits must be 2, 4, 6 and 8 in the column, and we've got 1, 7, 9 into those squares, these squares must be a 3, 5 pair. They must be the other odd digits, mustn't they? But these aren't on whisper lines. Okay, I'm not seeing anything else, so... right, perhaps we do have to venture further afield and have more thoughts about the world. So let's have a look at our other Scrabble bag. Now, have we got anything similar going on? We've got the sort of the rim of the bag poking up into this 45 cage here. We've got 3 even digits in row 4, but no 4th digit yet. If this was a 2, then obviously we would be in clover, because we would know that the rest of this row had to be from 1, 3, 5 and 9. So what else have we got going on? We must have... I presume it's... I hadn't actually thought very hard about this until I just thought of it again now, which is that I presume this isn't set related. If it was set related, it would presumably involve this cage. Let me just highlight this cage for a moment and think about that. Is there some other group of, either a complete row column, a complete row column, or a complete box that we can overlap somehow with this and say they contain the same digits, and do a long Scrabble bag explanation involving actual Scrabble bags in the grid, which would be quite cool. I don't know actually. No. Right, we're not doing that. We're going to do something different. I'm going to use red though, because that stood out so nicely. Right, I'm going to think about this digit. This is rather pretty. Now, this cell here, we don't know what's in it yet, but we do know that it has to make an appearance somewhere in our 9-cell cage. But look how many cells this sees already. It sees all of those in the box. It sees those in the row. And could it be the same as this? Well, no, because these are adjacent digits on a German whispers line. So we know that they have to be, if this is high, this has to be a low digit. So it certainly can't be the same digit. So that means that cell goes there, which means it's not 9, because we know that the 9 in this box is in this domino, so it's not here. So this cell cannot be 9 anymore. So this red digit now is in either, well, it's in one of these 3 cells. But it would be very nice to know it wasn't in this one, wouldn't it? Then at least we would know this would be 2, 3 or 7. So, what can we say about this digit? We can say it's not 1. That is a realistic comment, because it sees 1 in its row. It can't be 5 because it's on the whisper, and it can't be 9. So it is not 1, 5 or 9. It is either 2, 3, 4, 6, 7 or 8. And Okay. But if it was an extreme digit, if it was a 4, for example, it would have to be flanked on both sides by 9. That doesn't work here. Right, so it's not 4. So its options now are 2, 3. Oh, I see. Yeah, hang on. It's not 6 either for the same reason. If this is 6, you have to put 1 in the adjacent cell, and that 1 will rule that out. So this is either 2, 3, 7, or 8. But the problem is that they are very much, there's a couple of options below 5 and a couple of options above 5, and that's not what we want. We want to limit the options of this to just one side of 5. And man, everything here is still possible. So we know one of these cells is red. Oh, that's beautiful. Wow. Olimar, that is beautiful. Right, okay, so what we naturally need to do now is to focus harder on these digits. Because these digits, by Sudoku, have to make an appearance in this column somewhere. So these 3 cells have to go in this column somewhere, but they can't repeat in the cage, so they're not in these cells. Now, let's examine that more carefully. The 7 clearly already makes an appearance down at the bottom, but this cell, which is a 2 or a 3, can't be in those cells, so it must be in one of those 2. So that cell is in one of these 2. And this cell, I think, is the same. We know this can't be an 8 or a 9 because it's in the 28 cage. It can't be a 7, it sees it, so it's not in the bottom of the cage. It's not in the bottom of column 4, and it can't repeat in the cage, so it's not in there. So that cell is also purplifiable. These are purple. These are now purpled, and these 2 digits go into these 2 cells. And that's weird as anything. So that means this is 7, doesn't it? This is really strange, but I think quite beautiful. So these 2 cells we knew appeared in one of these 3, but we've just worked out that these 2, the purple ones, go in this domino, so they can't be red. So the only option left is for red to be 7, I think. And the 7 is a sunny number. So we can de-redify it and now go along this Scrabble bag with those cells and heat them up and make the other ones cold digits. And that's not 9. 9 is a warm digit, so it can't go in a cold cell. So this is a 2, I want to say, because it's next to 7 on the line. You can't put 3 or 4 next to 7. So this is a 2. So this is not a 2. So do we know? It would be very interesting to know if I can limit. What I'm wondering is this digit the same as this one? Or is it this one? In which case this would be 1, 3 or 4. This would be 3 or 4. I'm not sure. There's probably a way of telling that, but I can't see what it is. So what we probably need to do is to take the path of least resistance here, which is going to be to pencil mark my Scrabble bag over here. So let's do the low digits first and work out which ones of these can't be 4. That can't be 4, it's next to 7. So this is only 4. This is only 1 or 2. This one is next to 7 but not on the whisper line, so that one could still be 4 if it had. Oh no, if it's 4 it needs a 9 here and there's no 9 there, so that's not 4. If it's 3, this would have to be an 8, and this would have to have 8 on both sides of it because of this 9. Might be possible, don't know. This can't be a 4 because it would put a 9 here. This can't be a 4 because it would put 9s on both sides. I've now got a 1, 2, 3 triple in this box, which must be important somehow, probably. Sorry, I'm not quite seeing how to do that. But then, okay, this one, that one could be... No, that one can't be 4 either. Oh! Hang on, that's a high digit, and it's C789 in its box, so that's a 6. Oh, that's interesting. Maybe that was the way to attack the puzzle, actually. I'm just wondering that, because once you get that this is a 789, I know one of those digits on this German Whispers line had to be a high digit. So we could have said right at the start one of these is a 6. I didn't spot that. Oh, and now look. So now I've got 6 and 2 here. So these squares have got to be 4 and 8 because they're even, and there's an 8 looking at that one. So that's 4, that's 8. So, right, what does that mean? Is that really useful? Well, it's very useful for the Whispers line. This 6 has got to be next to 1 on Whispers lines. So these become a 2-3 pair, which means 6 can't go next to them anymore. So where do we put 6 in box 9? The answer seems to be only here because of Sudoku combined with whisperiness. So that's a 6. Okay, so there's a... Oh no, we don't know. There's a 6 in one of those two, but obviously 6 is even, so it can go very much in the square cell. So this cell has to be a 4 or an 8 now, because it can't be 2 or 6, and it's even. 8 has to be in one of these 4 cells in box number, in this 9 cell region. 2 and 3. Okay, so these cells here, oh I see, these are a 7. Oh yeah, this is nice. So these 3 cells have got to be 7, 8 and 9 because they're sunny digits and the 6 is not available. So that is a 4, which means this is a 5. So now, so now I have a 4-6 pair, both of which are even down here. That's not able to be 4 anymore. Doesn't prevent this from being 9, but at least... and now I've got a 1 here. Oh, this is flowing very nicely. So now I've got a 2-3 pair here, which makes this a 5, which makes that a 3. And I can write, well, I can write in the options for these squares, which are 1, 7 and 8. And that has to be an 8 because it sees 1 and 7 in the column. So I've got a 1, 7 pair now left. I've got... what else have we got here? This can't be 7 by Sudoku. This can't be 9 by Sudoku. Oh, so this can't be 4 anymore because it would need to be next to a 9. So this is down to 1 or 3. Oh yes, and I've got to remember this digit is the same as one of those purplified digits as well. So let's try not to forget that. I've got a 7, 8, 9 triple in this row. Yeah, okay, so these squares are 2, 3 and 5. And that's not 5. And that's not 5. So 5 is placed in box number 8. And that presumably is useful in some way or another. Although I can't quite see how to do that. That's not 3, I'm now seeing. So if this is 4, this is 9. That could be 2 or 3. Okay, should we fill in the options for these cells then? These have got to be 2, 4 and 6 and see if we can do any eliminating. But unfortunately it looks like we can't. 2 can't go there because it would repeat in the 9 cell region. So this is 1 or 3. Oh, I see. Yes, okay. So the question I should be asking is where does 2 go in this box? And because it can't repeat in its own region, it's in one of those 3 cells. And that means it's not here. So this has become a 3, which can't be ever next to 7. So this becomes 8 or 9. That doesn't do anything. Bobbins. No, it really doesn't seem to do anything. Oh, okay. So 2, 2, there is a 2 in one of these 2 cells. but we don't know which one. At least I don't think we do. Oh, this can't be 6 anymore, look. Because if that was 6, it would need to be next to a 1 on its German whisper. So there's an 8-9 pair now in this box. So let's have a think about that in the context of what we've got left to place. We've got 2, 4, 6, 2, 4, 5 and 6 to place. So this digit is 2, 4, 5 or 6, but it's not 2 because it would have to then go here, because it couldn't go here and it would see this 2. If it's 4, it has to go here, and that would seem possible. If it's 5, it goes here, and that would seem... Oh, I tell you the simple deduction, and that is that this 4, 5, 6 has 0 overlap with the 1, 3. So that means this must duplicate here. That's lovely. So this is a 4, 5 or a 6, and this is a 3, and that fixes that cell. Good grief. Wow, okay. So 1 finds a home in this rather empty box at the top of this column. This digit is a 4 or a 6 now only, because it sees a 2-8 pair. So it looks like we've got the bones of something going on, but not quite. Oh, and this digit has to make an appearance in box 6, and it has to be there, which means it's not a 6 look. So we can take 6 out of those. We get this down to being 4 or 5. And that must be nearly... It feels like it's nearly important, doesn't it? It hasn't quite resolved everything. What's that digit? 3, 5, 7 or 9. So it sees 3 and 7. So I think that's got to be 5 or 9 only. Yeah, one of these... Oh, yes. Yeah, well, let's use that. One of these is 9 from the logic we did earlier, where we worked out 9 in row 4 had to go here. So 9 in the 9 cell region has to go here, which now sees that cell. So that becomes 8, that becomes 9, that becomes 8. That can't be next to 4 on the whisper, so that's a 2, that's a 1. 1 and 7 go in at the bottom. 3 here is doing the 3 and the 2. I've only just seen that. That's now a 2 by Sudoku. And does that keep going? Come on, keep going. We've got 4s, 5s and 6s left by the looks of things into these cells. I'm sure this is resolved somehow. What's going on in this column? I've got a 4, 6 pair at the top. And I've got a 4, 5, 6 triple in column 1. So these two squares can only be 2 and 9, which means these two squares must be 5 and 7, which means that is not a 5. So it's still not quite resolved. There's something else I need to appreciate here, and that is going to revolve around what? Maybe I meant to pencil mark this cage it fully. That could be true. I need to put 1, 4, 5 and 6 into it, although I don't really like the look of that. 1, 4, 5 and 6. This digit, which ought to be the most restricted, is not restricted at all. Right. Okay, maybe no, I was about to claim something. Oh, there's an 8 here, so that's a 9. Okay. And there's a 3 here, and that's connected by the whispers line to this cell, which cannot be a 7, because that would only be 4 away. So that's an 8, that's a 7. We put 7s into these squares, or take 7 out, sorry, so that becomes a 7. That can't be next to 3 on the whisper, so that becomes a 2. That becomes a 3. Now is that doing some work? So we get 7 at the top of the grid up there. We've got 3 here is resolving the bottom of the grid down here. So we're just left with this 8-9 pair, which I'd like to resolve, but I'm not seeing immediately how to do that. We've got a 4-6 pair over here. We've got a 4-6 here. So something around here is going to resolve this, which is going to resolve that. I think that's where we're getting to. And what else can we do? 5 is nearly restricted in the middle box, but oh no, it's not actually. It's got 3 positions. I was missing this pencil mark. Okay, so that's useless. So it's got to be something probably to do with what? Let's check this digit then. I haven't pencil marked it. It's not getting much love. It's got to be 4, 5, 6 or 9, and it can't be 5, so it's 4, 6 or 9. That does not feel like that's restricted enough. Oh, so the question I should have spotted is that 1 in the box has to go there. That's a little bit of a bonus. So 6 is at the top. So we can ask where 6 goes in this row now, and it's got to be in exactly those 2 cells, because it can't go here because there's a 6 in this domino, and it can't go here by Sudoku. Oh golly, I thought that 7 was repeating in this cage, but it's not. So what digits have we not put in this cage, or even pencil marked in this cage yet? One of those digits is 3. So 3 must be in one of these 2 cells. Oh, there's a whisper cell. Oh, Simon, look, this is a whisper cell. I just hadn't even pencil marked it. Look, and it can't be 6, 7 or 9. That's probably what you've been shouting at me about. Oh, that's 8 and 9 going down here. So 9 goes here, which, oh no, I was about to say it pushes the 2 over, but it doesn't at all. This, though, does push the 2 over, so that's good. So does this break the puzzle open? This cell, yeah, that's got to be 4 or 5 by Sudoku. It sees this 6. So the only place 6 can go in that row is here. So we've now got a 4, 5, 9 triple in our 9 cage, which means these squares have got to be 3 and something, 3 and 6. So that 3 is placed here. That's a 6 now, which places the 6 in this box. 1, 2, 4, 4, 5, 7, 9. 4, 5. This is a naked single. It sees a 4, 5 pair. That's a 7 only. 4, 5. 4, 5, 9 now. So this is a naked single. That's a 5. So these become, so this is 4 and 9. That gets placed. That removes 4 from these squares, which finally I get this digit as a 4, which means that's a 4, which means that's a 4, that's a 5, that's a 9, that's a 5, that's a 6. 6 and 4 go into the bottom, and that should be a 5. And we have a great deal of information about the bottom 7 rows of this puzzle now. So hopefully we will be able to finish it. Let's see. So 2, 4 and 6, that's even, so it's got to be 8. Somehow that doesn't do anything. These squares have got to include a 1, so we can do that. These have got to be 3 and 7. Oh, which is not resolved. This is a 1 now by Sudoku. That's going to allow us to put a... That's 3 in the corner. That's 3 in the spotlight, losing its religion. Very nice indeed. Oh yes, this is actually going, isn't it? So that's a 4 by Sudoku. We've not put 2, 8 and 9 in, so that's 9, that's 9, that's 2, and that's 8. And I think that is how to solve a very cute puzzle indeed. Lovely. Very much enjoyed that, Olimar. That was very cute indeed. I loved the Scrabblebag theme. And actually, I actually really like the solve. I think what was going on with this digit having to be here, using the whispers to avoid it being here, was beautiful. And then I never quite understood this, but the fact those 2 digits then had to go there, and that forced the nature of this digit, that just surprised me. I think the logic was good. I just feel like I should have spotted it more cleanly. But anyway, we'll take dirty solves occasionally too. Hope you enjoyed it. Let me know in the comments. I do enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.